Let me talk about chemical calculation. Now it's 9:59, right? I want to overrun about 3 to 4 minutes, all right? If you can, and I suppose you can, all right? Stick with us for a while, all right? So here we go. Chemical calculations. So again, titration. Ensure that all the answers are given to 3SF, even if answer is an exact value. Be careful, the final answer you wrote, your mole calculation, not the reading or result, is this value is wrong. It must be shown this way. Everyone okay? 3SF. Cause I'll mark you wrong. I'll take away 1 mark because you write this. Because you do not present your answer in the lab. Alright, check all your practical papers again. Alright, you should have been marked correct or wrong by your teacher. They'll put a tick on, okay? Or a cross. And likely to write something. Except when question asked to fix X in the hydrated salt or mole ratio of two reactants. Answer, obviously, in mole ratio. Everyone okay? X number of H2O must be 1, 2, 3, 4, 5. Can't be 1.2, 1.3, doesn't make sense. So that one, you have to round up or round down. Again, a lot of common sense in place. Now, use 5 significant figures from previous part in the calculation for the next part. You have to use it because of accuracy. It's better. All right, so you can All right, answer in 3 sig fig, you go 5 sig fig. You will never have error. The error is minimized by a lot, okay? By having 2 more significant figures. Okay, now, here you go. Key source of the error. I want to complete this plus something else. This is the one that you all wanted to look at, right? Key sources of error for titration. Okay, I need to think through this because I want to go through so that I want you to think through. What's the error? Acid alkali, also known as acid carbonate, right? It's the same, right? Acid alkali and acid carbonate. For example, all right? These two are very similar, all right? Kind of titration. Now, if your titrant results, right, the one in the burette, you get a volume of solution Q, i.e. the titrant, i.e. the burette reading, okay? It will be higher or lower value than expected, if there are acidic impurities in P, i.e. the one in the conical flask. Okay, very generic because I never give a lot of example, I just put in one line. So let me run through a bit more. All right, I use color code. So what do you mean by higher? Let me write this out. Burette is a titrant, remember titrant? So if the titrant is alkaline, let's just stop here, okay? Copy this in. Yeah, so burette reading is higher. So instead of say 25 cm3, like I do more calculation, it should be 25 cm3. But wow, it's 27, 28, 29 cm3. It's like a lot higher than what I should get. Why? Is because my conical flask, besides having an acid that I'm titrating with, it got acid impurities. Are you with me? Not the acid, but some impurity that's acidic. So now the conical flask got the original acid, but you also got other acid that's impurity. So obviously the titrant need more. Make sense to you, everyone? Okay, key sources of error. And the opposite must be true. Here we go. This is lower when the titrant is acidic. The opposite. Is that okay? So let me run through with you, right? Top and bottom, right? Once again. So let's read the line again. There may be acidic impurities in P, the conical flask. So there's acid inside here. On top is alkaline, right? Okay. I reverse it. I say wrongly. All right. Towards the end, always like that. Okay. Let's do it one more time. This time out, light blue is where my titrant, my burette, look at the top first, is acidic. Right? Hits here. Okay. So my conical flask, sodium hydroxide, alkaline. Is it okay? This is alkaline. This is alkaline. So my conical flask is alkaline, sodium hydroxide. There might be some acidic impurity inside there that really react with my alkaline. Are you with me? So my sodium hydroxide is less. Makes sense. So when it is less, on top, come down, also need less to react. So the value will be smaller. Make sense to you? Okay. I repeat myself, the light blue. Okay, light blue, what's the story? Light blue, this is a story. This is sodium hydroxide, the titrant. Yes. And the buriate is this. Buriate is acid, HCl. Is it okay? So the titration is like that. Make sense? So they will have a certain, you need certain volume to, so that they react just nice, correct? So the mole is just nice. So they react just nice, all right? So, however, there might be some acid impurities. There's some acid impurities. Correct? So what will these acid impurities do in the first place? These acid impurities will react with some of these already. Yes? Agree? So it will have reduced your sodium hydroxide concentration. Make sense? Or the amount inside there. When this is less, obviously, this one shishi down also need less. Everyone okay? Make sense to you? Hello? Just draw it all. It's all done by drawing the two apparatus. And you should get it. Okay? So the opposite is always true. I don't have to go through. Is it all right, everyone? Can I just let you run through this on your own? Draw it out. Label, you will sure get it. That's all I want you to do. All right? So that's your homework for tonight. All right? This workshop by right, no homework one. Redox is the same thing. Remember, there's always oxidizing and reducing agent. So you do the same thing over here. And you will get it. Is it okay? So I'll not discuss this further. Okay? Okay, think about it. This is your only homework up to tomorrow 7 p.m. that I need you to do. Okay? If you're still not sure, someone voice out right at the start of tomorrow's day 2 workshop and let me know. Is it okay? Can I? Now, there's something I never give you. All right. So can I have 2 more minutes here? I always hardcore one. All right. So this is what, if you want, can take a picture, because I cannot send, I cannot give you all this because this belongs to my students. I think it's very rude that I give it to you. All right. Not this year's students, so don't worry. Some of you will look at it, this is my answer. No lah. These last few years, I won't use this year's one. So sensitive. And I won't put a name. Okay, and the photo, obviously. So ladies and gentlemen, take a look. If you want, you can take a picture, but I want to just let you see, take a look. First one over here is they want you to test justification of anion. All right, so they ask you to do something to find the anion in Z, a salt Z. All right, so salt Z is what? And then justification for the anion. And I think there's a cation also. So cation should get he or she. I think it's she, and I think so nice. All right, but the anion, her answer is not good, right? It's true, it's carbonate. The answer is really carbonate, right? Carbonate, which I saw somewhere here, carbonate, all right? But you look at his or her answer, should be her. When X is added with dilute sulfuric acid, effervescence is seen in solution, thus carbon dioxide is produced. This girl never do what? Never do lime water test. Are you with me? Can you see? So she got 0 for that part, which we all know the answer is very easy. First, you got effervescence. And after that, we talk about the lime water test. Produce YPT, lime water, and therefore that confirm carbonate ions. Everyone, are you with me? Correct? Know what to write. Please, not suka. I want to write this, I don't want to write this. Not your choice. Sorry. Okay? Theory paper, we are more lenient. Practical paper, we are not lenient. All 3 sciences are the same. Okay? So next, this one, nothing much. I find those that is a bit more fun one. Okay? I want to show you. This is the one. Do you remember what I said just now? To a portion of P should be a solution. Add an equal volume of aqueous silver nitrate. Are you with me? Which we know is used to test for iodide, chloride, whatever lah. Here, because it's iodide, that's why they wrote iodide. I didn't write all this. So do you see what happened? Question mark? -1 mark. Solution remains colorless. You cannot. Or no visible observation, cannot. The answer is no PPT observed. Are you with me, everyone? Because you know what you're testing. Same thing, barium nitrate to the same one. All right. So what happened? We are testing for sulfate ion, barium sulfate. Everyone okay? So he saw nothing. She saw nothing. She must write no precipitate. Cannot write like that. Okay, everyone? All right, just want to show you all this live. No, my answer. Okay. Next, remember this. When you add aqueous sodium hydroxide, boil it, add piece of aluminum foil, warm. This one is whereby we test for NO3 minus. And what came out? Ammonia gas came out. All right. This one came out. So she only get half the mark. She go and test it. She say, oh, litmus paper on ammonia, right? She actually got it wrong. Should be moist or what, right? She didn't even write moist. Moist red litmus paper turned blue. I should mark her. The teacher should mark her wrong. All right. So by right, this one mark. But she was penalized on the first part. If you don't have, always must say a pungent gas. Because ammonia come out sure got pungent one. And that's where then you go and test it with moist red litmus paper. Everyone, are you with me? Can? And you look at it, the last line, the teacher don't bother to do anything. Dissolve, law. This is not a key observation. Are you with me? Correct? Nobody cares. Dissolve lah. What's the big deal? All right. So you want to write, you say, okay, I won't penalize you. All right. But there's no brownie points. All right. Almost done. What else? This is the one. Look at it now. Record result. The table of titration, I think. Look at what the student wrote. Volume of P added. This is wrong. Remember, you must follow a certain, not the English you want to use. Volume of P left. No, it's not. It's called reading. Then what's called titration successful. Don't write the word successful. Do you realize that or not? Don't write. Don't kepo. And do you see what happened? Do you see? All the DP, all wrong. The accuracy. All right, never follow instruction. So she do all experiment, all correct, but 2 marks out of 5. You saw? She lost 3 marks. And this is the one. All right. Do you see what I see? 1, 2, 3. Don't know how to do average value for titration. You don't use 3. Correct? Again, just to show you, cannot write volume. It's called reading. Do you see? 3 marks gone again. And never go to minimum. Is it okay? And never say best titration result. Skip one row. Everyone okay? Because you're supposed to have the row to tick. Can? All these I discussed earlier. I'm going to show you just live. Again, don't know how to do average. This is another student, a different one. Right? This is by right the correct answer. Okay? Because talk is cheap until I show you. All right, ready? Remember, all calculation must be what? 3 significant figure. What did she write? 2 sig fig. Who teach her? I don't know. Because it's a round number, exact number. So she forgot to put a 0 there. You need to put in. Okay? And units must be in. Gram. Significant figures. How many? 3. She wrote 4. Okay? She lost the mark. She done all the experiment and she lost all the marks. Well done. He or she, this one. Probably still she. Everything so nice. Okay, last one just to show. I think nothing much on this one. This is the time. Because everyone like to talk to me about time, right? Stopwatch, ladies and gentlemen. What did the student write? The stopwatch very accurate of the school one. Very good. Oh, I see. Can go for Olympic. Or wrong. This is the answer. Wrong or wrong now. Is it okay, everyone? Can? Anyone want to ask anything? Want to contest anything? Don't have. I hope day 1 is useful to you. Hard work, but we went through the basic. Tomorrow we continue with this set, talk about key sources, other experiment, and then we look into planning question. All right, will be more theory tomorrow. Less of numbers here. Okay, looking at numbers itself. If not, thanks for sticking with me. I'm always hardworking. I hope you are more hardworking than me. That's all I'll say. And always think, and you'll be fine. All right, if not, have a good evening and a good rest. I'll see you back tomorrow at 7. And Catch you soon. All right, bye bye. Take care.